For this video clip, we want to find the scalar component of the vector A along vector B, and then we use this process to find the projection when you have the vector A and vector B, and you want to find the projection of vector A down to the vector B, along the line of vector B. You want to find that kind of stuff, but first, for this EP, we want to take a look at the component, scalar component first. Here's the definition of scalar component of vector A along vector B is equal to the dot product of A with the unit vector that has the same direction of vector B. So as a symbol, you have here component COMP A down to B, subscript B, vector B is that A dot B divided by the modulus of vector B here. The component of vector A along vector B means to find the component of A in direction of B. Here's a situation geometrically, and this one we use a lot in physics. If you study engineering, you have to use it in anyhow, right? So assuming we have vector P and Q as these two examples, and vector P and R, PR, all right, you want to project vector PQ down to the vector PR. You're going to push vector PQ down here, and given you have the angle theta either there xq or obtuse here, you want to push the vector PQ down to the direction of vector PR. If you push it down, you will get the modulus PQ multiplied by cosine theta. All right, the same way you study in physics, right? And this one will match up with the scalar component as we have for the definition in above slide. So the reason why is here, well, you want to find PQ dot PR divided by the modulus of PR, but A dot B from the formula, remember, A dot B is the modulus of A times modulus of B cosine theta, and theta is the angle between vector A and vector B. So you get this here. Alright, and then modulus of B, magnitude of B and magnitude of B cancel out one another, so you get length of A times cosine theta. So that's another definition. That's another way you can find the scalar component of vector A in the direction of vector B. Here's a note that you need to understand. Scalar PQ modulus PQ times cosine theta is positive is theta is in between in the first quadrant. If it is negative, means it's in the second quadrant, and if it's 0, it means it's 90 degree. Alright, let's take a look at this example together. You want to find the scalar component of vector F 2, -1, and 3 in direction of this one. Well, you have two formula, right? You have remember, you have A dot B divided by modulus of B or magnitude of B, or you can do absolute value, not absolute value, sorry, length of A times cosine theta. But if you use the second one, you must know the angle theta, right? But in this example, the only thing that's given is just the vector, two vector, right? You don't know the angle. You can find the angle, right? That's fine. You can use the formula to find the angle, but that will take some time, and it will take 2 steps. but we want to do only one step. Okay, so here's the thing that I'm going to do. The answer for A is going to be you have to find f dot I divided by length of I, but the length of I it's just one, right? Just one. Okay, so you don't have to compute this, we already know it's just one. So you find f dot I, and f dot I is just 2 times 1. Okay, I is just 1 0 0, right? 2 times 1 plus 0 plus 0, so it's 2. Okay, all right. For A, for B here, you have to find f dot A divided by modulus of A, and for C you find f dot B divided by modulus of magnitude of B here. Okay, the solution is here. Okay, so I don't have to compute it, but the concept is just there. All right. Okay, now let's take a look at this example. I think it's more exciting. We have vector A and vector B given there, 4, -1 and 5. That's for A, and for B is 6, 3 and -2. And you want to find the component B in the direction of A. Okay, and then you want to find a component of vector A in the direction of vector A plus 2B. Okay, let's take a look at the first one. Component of B in direction of A, we have to use this formula. So you need to find the modulus or the magnitude of A, which is 42, square root of 42. And then you do dot product B dot A, you get 11. So it's going to be 11 divided by square root of 42. And for the second one, you want to find the component, scalar component of A down to the vector A plus 2B. So you need to find A plus 2B first, which is 16, 5 and 1, and find the modulus. You get square root of 282. Okay, and you use the same procedure. You find the dot product, and then you divide it by the modulus A plus 2B. Okay, then you get 64 divided by square root of 282. Okay, that's a scalar component from one to another one. Now let's use that result to find the projection factor. Okay, so we already know how to find the scalar component, and we want to add in more information. If you know the scalar and you know the direction, you're going to get the projection factor. Okay, the projection factor A, PQ. So let's take a look at the figure together with the explanation above here. Factor A is a PQ, which is here, along the non-zero vector B. Vector B is right here, PR. Can be determined by dropping the perpendicular form Q to the line PS. Okay, you're gonna drop this guy down here. The notation we're gonna use is a projection A down to vector B, vector A to vector B, and here is the formula that you want to find the projection if A and B are non-zero vector. I think, yeah, A is non-zero. Okay, then the projection vector A along B can be found by using this formula, the scalar component A down to B multiplied by the unit vector in the same direction as vector B here. Okay, let me explain from here. We know the scalar already, which is the length of PS, but you want to find a vector. if you want to find a vector, you need direction, right? You need to add direction, and the direction is the same of PS is the same direction as B, right? But if you just multiply it by B, you get the direction of B, also the scalar of B, the length of B. Then you're not gonna get PS, but you're gonna get something bigger or smaller vector. So you have to normalize vector B to the unit vector, okay? Normalize it to unit vector. Okay, so if you normalize it, you're gonna get vector B divided by the length of vector B. Okay, so this is the formula, and if you derive it, remember the component, scalar component, it just, this guy is just A dot B, right, divided by modulus of B. So that is the formula. Okay, now let's take a look at this example. You want to find the projection, right? So use the formula. Okay, you have vector u and vector a, and you want to find the projection vector of u along a. So you're going to push u down to a. Okay, so the formula is here. The projection u down to a is u dot a divided by just the length of a squared times, okay, times vector a. Here, oops, this is the multiplication. Okay, so you have to find u dot a first, which is just 15, and then you find the modulus of a, or the length of a, it's just square root of 21, and then you put everything in the formula, and you get the resulting vector, which is the projection vector of u along vector a. Okay, this is the answer. All right, so that is the end of this e-pay and video clip. So good luck for everything, and for the next video clip, you will see Ajahn Powertone or Ajahn Mike. He will explain about the application of vector work done by Ford and something else that is exciting. And I hope everybody understand everything. We try to help you, and according to the situation we have, we can't meet each other in class, but we try the best to help you. And good luck for the final exam, and stay healthy, and hope to see you again in the campus sometime. Okay, all right, so that's the end for mine, and see you next time.